Today we've got a bag of bits to play with. Here we have a Raspberry Pi, a power supply for a Raspberry Pi, that's a lens, that's a USB cable, that's a mounting plate, and I think if you can see what's on the label you might have an idea. That's an HD camera module, and that's a USB card. So, and that's a heatsink. So with all those bits we are going to make an OctoPi, and it is going to fit on my Anycubic Vyper printer over there, and hopefully it's going to help control the 3D printing. It's going to let us have more control over the settings, and it's going to do things like time-lapse photography. So we'll be able to see what we're printing, which is going to be great. And let's stop waffling and let's get on with it. All the parts are laid out on the bench. I'm going to start by attaching the heatsink. This has an adhesive pad on the back, so it's just a matter of peel and press. It turns out there was already an SD card inside the Pi, so I didn't need this one after all. Now we have to fit the camera module to one side of the plate and the Pi to the other. This is pretty much trial and error, since the only guide is the picture on the packet and any photos on the website. Let's fast forward through this. Hurrah! And the HQ camera has a 1/4 inch thread on it, so we can bung it onto a regular camera tripod. Now the Pi Cam is built, we need to install some software. So let's cross the office to my iMac. This is actually a pretty straightforward process. First we insert our micro SD card into the reader. Next we need to run the Raspberry Pi Imager. If you don't already have it, you can download it from raspberrypi.com. It's available for Mac, Windows and Ubuntu. Click on Choose Operating System. Scroll down to Other Specific Purpose OS. 3D printing, OctoPi. Click on the Stable Release button. Now we tell it where to install it, so choose Storage. Pick your SD card from the list. Click Write and job done. Well, pretty much. Before we remove the SD card, we need to set up our username and password so that we can log into it. Now we can eject the SD card and put it in the Raspberry Pi. There's a little compact flash card. Oh, there it is. So it goes in like that. We can now take this over to the printer and we can start it up. Okay, so the Pi is set up on the bench, and now we'll just plug it in. Take the new power supply out. One end goes into the mains and the other end goes into the USB-C. Now we should see some LEDs flashing. As you can see, I've connected it to the hardware Ethernet rather than go through and configure Wi-Fi. I think maybe that's done. Oh no, it's doing some more. Okay, so the next thing to do is attach the Raspberry Pi to the printer. So we've got our standard A to B USB cable. Goes into there. And into one of these. I'm not sure that it matters which. And I guess we turn the printer on. Okay, that was exciting. Back on the computer, bring up your web browser and type in octopi.local. This will connect to the Pi and start the first use setup wizard. The first thing we set is username and password. Then we just work through the screens. Mostly we can accept the defaults. Finally, we tell it the name of our printer. Okay, so OctoPrint has now connected to the printer, and we can see we've got actual temperature, actual bed temperature, and we can see what's on the SD card. That's interesting. Okay, what we didn't manage to do is set up the printer profile. So let's go to the options screen, printer profiles, Vyper, Anycubic Vyper, that's the one we've got. That's what we set the name. We didn't go into here, we didn't set the print bed and build volume. Heated bed, yes. Width is 250, depth is 255, and height is 265. Okay, so that's done. Save. We could run with this setup as it is. OctoPrint will control and monitor the print. We can save G-code out of Cura onto an SD card and OctoPrint will print it. But what if Cura could talk directly to OctoPrint? Well, it can. We need to create an API or application key in OctoPrint. We can do this through Settings Application Keys. When that's done, we'll copy it to the clipboard. Now we can start up Cura. There's a plugin that we need to install in order for it to talk to OctoPrint. So click on Marketplace and select Plugins. You'll need to be logged into your Ultimator account for this. Scroll down until you see OctoPrint Connection. You can also find it through the web marketplace. Click to install. Now you can go into Manage Printers and you'll see the option to connect OctoPrint. Click on this and you'll be asked for the API key that we generated earlier. Paste it into the box and we can connect. There are some more options that we can select. So with all that done, let's slice something and get it to print. I've picked this user port connector cover that I downloaded from Thingiverse. The link is in the description. Once it is sliced, you'll see that the Save button now says Print with OctoPrint. Off camera, I've loaded some filament into the printer, so we should be ready to press print in Cura and see if it works. You can't see it from this camera angle, but the network light is flashing away on the Raspberry Pi. And also the build plate temperature is coming up in Cura. I wonder if I should take the lens cap off. Okay, the camera still needs focusing. I'll do that later. There we go, the build plate's moving. We can switch to OctoPrint and see the live feedback from the printer. There's still some camera setup to do, but it is going. We have an OctoPi and OctoPrint and an OctoPrinting OctoPi. Woohoo! And on that note, click the like button if you like the video. Click the subscribe button if you want to see more. And now the print's finished and I've got the camera in focus. It was really just a matter of turning the focus ring a lot more than I expected it to go. But there it is. I can now think about the best place to position it and maybe installing some other plugins like Optolapse. But all that's to come. Like, subscribe, and I'll see you next time. See ya! That's a that's a HD